The journey of Boston Dynamics' Atlas humanoid robot is one of the most inspiring stories in modern robotics. Boston Dynamics' Electric Atlas is the next-generation, fully electric humanoid robot, unveiled in April 2024 as a stronger, more agile successor designed for real-world commercial applications like manufacturing, with unprecedented range of motion that exceeds human capabilities. But before there was the groundbreaking Electric Atlas, the iconic Hydraulic Atlas wowed the world with feats like parkour, backflips, and dynamic manipulation. Let's take a look at some highlights from its impressive legacy. It all begins in the pioneering work of the Leg Laboratory at MIT, led by Mark Ribert in the 1980s and early 1990s. In the Leg Laboratory era, from 1980s to 1990s, researchers developed groundbreaking one-legged, two-legged, and multi-legged hopping and running machines. These early dynamic-legged robots laid the scientific foundation for balance, agility, and locomotion in machines, proving that robots could move with animal-like grace and recover from disturbances. This research directly inspired Boston Dynamics, founded in 1992 as a spin-off from that work, and set the stage for truly mobile humanoids.
Back in 2004, Boston Dynamics unveiled Big Dog, followed by Rise, a six-legged robot in 2006, RHEX, another six-legged robot in 2007, and LS3 in 2008. These quadrupedal robots were specifically engineered to navigate difficult terrains and steep mountains. The company unveiled its first bipedal robot, PETMAN, in October 2009. Little Dog was launched in 2010, followed by Wildcat in 2011 and Cheetah in 2012, both focusing on achieving high speeds. Sandflea, launched in 2012, was built to vault high in the sky. Spot Classic, launched in 2015, laid the groundwork for the agility and compactness seen in Spot today. The initial version of the popular bipedal robot Atlas HD debuted in February 2016, undergoing several iterations since then. Spot, the most popular quadrupedal robot from Boston Dynamics, was launched in June 2016. This was succeeded by Handle in 2017 and Stretch in March 2021. The Factory Safety Service robot was released on September 17, 2021. Additionally, Boston Dynamics introduced PIC in early 2023. Upgraded version of Spot 4.0 was released in 2024, followed by All-Electric Atlas in the same year. Let's examine each one of them in greater detail. Big Dog, developed in collaboration with Foster Miller, the Jet Propulsion Laboratory, and Harvard University's Concorde Field Station. Designed to traverse challenging terrains, Big Dog featured four legs measuring 3 feet in length and standing 2.5 feet tall, similar to a small mule. Funded by DARPA, this project aimed to enhance military logistics by assisting soldiers in navigating difficult environments. Despite its innovative design, Big Dog's operational noise proved unsuitable for combat missions. Nevertheless, its ability to carry loads up to 150 kilograms at speeds of 4 miles per hour, along with exceptional stability against impacts, set it apart as a pioneering legged robot. Boston Dynamics continued its trailblazing with Rise, a six-legged climbing robot launched in 2006. Rise uses specialized feet and motions to grasp microtextures on surfaces, developed in collaboration with researchers from UPenn, Stanford, Berkeley, Carnegie Mellon, and Boston Dynamics, funded by DARPA. RHEX, weighing 30 pounds, was purpose-built for navigating challenging terrains. Controlled remotely via RF link with a high-resolution video uplink, RHEX demonstrates versatility in operating upright or inverted, boasting a battery life of up to 4 hours. It prioritizes ruggedness, extended battery life, ease of maintenance, and enhanced mobility. The Legged Squad Support System, or simply LS3, also known as AlphaDog, represents a militarized advancement from Big Dog, designed to endure extreme conditions and rugged terrains. LS3 combines the load-carrying capacity of a pack mule with intelligent navigation abilities, utilizing onboard GPS, LiDAR, and infrared systems for autonomous operation. Despite challenges in voice command responsiveness, LS3 can cover distances up to 20 miles without refueling, offering advantages over biological pack animals. In addition to these projects, Boston Dynamics embarked on other groundbreaking initiatives. PETMAN, an advanced bipedal robot, was developed to test chemical protection gear, capable of dynamic human-like movements and physiological responses crucial for evaluating protective attire effectiveness. Little Dog, introduced around 2010, is a compact four-legged robot used for DARPA research. It serves as an experimental platform for various institutions, equipped with agile legs powered by electric motors, an onboard computer system, and sensors for monitoring joint positions and motor force. Little Dog operates for up to 30 minutes on lithium polymer batteries, facilitating remote control and data collection via wireless technologies. In high-speed robotics, Boston Dynamics achieved notable milestones with the Cheetah and Wildcat projects. The Cheetah project set speed records exceeding those of the fastest human runners, while Wildcat emerged as the fastest four-legged robot globally, renowned for its stability across diverse terrains. Wildcat is a quadrupedal robot designed to achieve high-speed locomotion across various terrains, demonstrating impressive capabilities. Wildcat has attained speeds of approximately 16 miles per hour on flattering, utilizing bounding and galloping gaits. Developed by Boston Dynamics with funding from DARPA's M3 program, Wildcat represents a significant advancement in robotic mobility. While Wildcat's current top speed of 25 km per hour falls short of Cheetah's 45 km per hour. The reasons behind this disparity remain speculative. Factors such as onboard power limitations, gait efficiency, and the relative novelty of Wildcat as a developing robot may contribute to its current performance level. Additionally, the robot's potential for refinement and optimization suggests room for improvement in future iterations. Furthermore, the extent of Wildcat's performance beyond controlled environments like parking lots remains uncertain. Questions linger regarding its capability for sensor-based obstacle avoidance, a feature crucial for navigating complex and dynamic surroundings akin to those encountered in real-world scenarios. Despite these uncertainties, Wildcat's development heralds promising prospects for advancing robotic mobility and autonomy. LS3, a robust robotic marvel, stands out as one of the fastest competitors despite not matching the lightning pace of Wildcats. Weighing 590 kilograms at LS3 surpasses Wildcat's weight, granting it enhanced toughness and durability. Fueled by a single tank of gas, LS3 can cover an impressive distance of 32 kilometers and remain active for up to 24 hours, carrying a significant load of 182 kilograms of gear. Guided by hydraulic actuators and driven by gasoline or diesel engines, LS3 demonstrates resilience through rigorous trials, handling payloads of up to 500 kilograms. Equipped with cutting-edge computer vision technology, LS3 operates independently, supporting 12 joints for leg motion, and employing LiDAR for autonomous navigation and seamless coordination in changing surroundings, making it an invaluable asset for supporting soldiers in transporting heavy loads across challenging terrains. In August 2012, the Cheetah robot, characterized by its 4 legs, achieved a remarkable speed of 28 miles per hour, setting a new record for the fastest land speed attained by a legged robot. Concurrently, another robot named Cheetah, developed by MIT's Biomimetic Robotics Lab, showcased its own remarkable advancements. By 2014, it demonstrated the ability to leap over obstacles while running, and by 2018, it had mastered the skill of climbing stairs. Subsequent iterations, such as Little Dog and Alpha Dog, further refined the original design, culminating in the development of the Legged Squad Support System LS3 in 2012. This updated version boasted enhanced versatility, enabling it to operate effectively across a wide range of environments. Sandflea, weighing 11 pounds, boasts a singular impressive feature. While typically maneuvering like an RC car, it possesses the extraordinary ability to leap up to 30 feet into the air when necessary. Equipped with an onboard stabilization system, it maintains orientation during flight, enhancing the view from its video uplink and ensuring controlled landings. Spot Classic is a four-legged robot designed for indoor and outdoor operation. It is electrically powered and hydraulically actuated. Spot Classic has a sensor head that helps it navigate and negotiate rough terrain. Spot Classic weighs about 160 pounds.
We're interested in getting this robot out into the world. Out in the world is just a totally different challenge than in the lab. You can't predict what it's going to be like. This isn't completely out in the world because there's that power tether, but we're working on a version that doesn't have that. And you know, all kinds of stuff happens out there, and we're making pretty good progress on making it so it has mobility that's sort of within shooting range of yours. I'm not saying it can do everything you can do, but you can imagine if we keep pushing, we'll get there.
In the realm of robotics, Atlas has stood as a beacon of inspiration and innovation. Originating from a Dakar project called PETMAN in 2013, Atlas was initially designed to evaluate soldier suits against chemical warfare agents, replicating human movements with remarkable precision. From walking to running, bending to reaching, and even simulating perspiration, Atlas pushed the boundaries of robotic capabilities. Introduced by Boston Dynamics as part of a Department of Defense contest, Atlas, towering at 6 feet 2 inches and weighing 330 pounds, captivated the world. Its ability to hop, jump, twirl and manipulate objects showcased its extraordinary agility. Over the years, Atlas evolved, continually expanding its capabilities, captivating audiences with its feats from running and jumping to dancing and even parkour. However, as Boston Dynamics shifted focus towards commercialization, the limitations of hydraulic systems became apparent. Challenges such as hydraulic fluid spills and maintenance complexity hindered its commercial viability. Boston Dynamics found success with Spot, an electric platform better suited for commercial applications, signaling a shift towards fully electric humanoid platforms. Spot, a remarkable creation by Boston Dynamics, heralded a new era in commercial robotics, finding wide-ranging applications in fields such as healthcare, law enforcement, and construction, owing to its autonomy and versatility. Unveiled on June 23, 2016, Spot represents a lightweight, four-legged robot inspired by canines weighing a mere 25 kg, making it lighter than other Boston Dynamics products. Spot gained significant attention in November 2017, when a video showcasing its ability to use its claw to open a door went viral on YouTube, quickly reaching #1 with over 2 million views. Another video in the same month depicted Spot persistently attempting to open the door despite human indifference, eliciting varied reactions from viewers. On May 11, 2018, Boston Dynamics CEO announced Spot's transition to pre-production, with plans for commercial availability in 2019. However, in September 2019, it was revealed that Spot would be leased to selected business partners, rather than being sold outright. In November 2019, the Massachusetts State Police became the first law enforcement agency to deploy Spot in their bomb squad operations. Spot SDK became accessible on January 23, 2020, enabling programmers to develop custom applications for various industries. On June 16, 2020, Spot became available for purchase by the general public at a price of $74,500. Spot's versatility was further demonstrated in various noteworthy events. In June 2020, a Spot named Zeus assisted SpaceX at their Boca Shaker Starship test site. In July 2020, a team of Spot robots served as cheerleaders at a baseball match in Japan alongside SoftBank Pepper robots. Spot conducted inspection tasks on the car floating production, storage, and offloading vessel in November 2020. In April 2021, a YouTube video showcased Spot dispensing beer into red plastic cups. While in March 2022, Spot created a painting titled Sunrise March, which was sold for $40,000 to benefit Ukrainian refugees. April 17, 2024 marked the debut of a fully electric iteration of Atlas by Boston Dynamics. This new version boasts an enriched range of movements compared to its predecessor, empowered by an advanced control system and cutting-edge hardware. It showcases remarkable athleticism and agility, establishing a pioneering benchmark in robotics. On September 17, 2021, the Factory Safety Service robot was unveiled, representing a pioneering partnership between Hyundai Motor Group and Boston Dynamics. Evolved from the well-known Boston Dynamics robot Spot, this innovative iteration features an integrated thermal camera and advanced 3D LiDAR system. With these capabilities, it adeptly detects nearby individuals' surveillance for potential fire hazards and distinguishes between open and closed doors, enhancing safety in industrial settings. Spot Mini, shaped like a penguin, exhibits exceptional talent in jumping, elevating cuteness to a new level. Holding the Guinness World Record for the most skips by a robot in a minute, its agility and speed shine as it flawlessly leaps over ropes, showcasing impeccable timing. With a total of 106 leaps, Spot Mini's achievement highlights its exceptional abilities. Fitted with various sensors, it ensures accuracy in tasks, smoothly clearing ropes without errors. Its soft and fluffy appearance enhances its appeal, making it an enjoyable and extraordinary toy for both kids and adults. Handle is a research robot developed by Boston Dynamics, featuring 2 flexible legs on wheels and 2 manipulator arms for grasping or transporting objects. Standing at a height of 6.5 feet, Handle exhibits remarkable mobility. Capable of traveling at speeds of up to 9 miles per hour and leaping vertically up to 4 feet. Its propulsion relies on electric power, enabling the operation of various electric and hydraulic actuators with a travel range of approximately 15 miles on a single battery charge. While Handle shares many dynamics, balance, and mobile manipulation principles with other robots from Boston Dynamics, it distinguishes itself with a simpler design comprising only about 10 actuated joints. Despite its reduced complexity, Handle showcases exceptional agility and efficiency in navigating diverse environments and performing manipulation tasks. Boston Dynamics unveiled the Stretch robot for warehouse automation through a video on their YouTube channel on March 29, 2021. This innovative robot features a square mobile base equipped with wheels, along with a perception mast containing cameras and various sensors. Additionally, Stretch boasts a robotic arm with 7 degrees of freedom and a suction pad array at its end, enabling it to securely grasp and relocate boxes weighing up to 23 kilograms. Pick, much like Stretch in its functionality, remains stationed in a fixed position. Designed primarily for handling boxes, Pick efficiently identifies boxes in less than a second. Additionally, it autonomously removes the cardboard sheet, streamlining the box handling process seamlessly. IHMC and Boardwalk Robotics are collaborating on Nadia, a next-generation humanoid robot designed for high mobility in urban environments. Named after gymnast Nadia Comaneci, Nadia aims to achieve human-like range of motion using innovative mechanisms and composite materials. Funded by the Office of Naval Research, Army Research Laboratory, NASA Johnson Space Center, and TARDEC, Nadia integrates electric and hydraulic actuators, including Moog's integrated smart actuators and custom motors for optimal performance. The project targets applications like firefighting, disaster response, and explosive ordnance disposal, aiming to extend human capabilities safely in hazardous environments. Boston Dynamics' commitment to pushing the boundaries of robotics is exemplified by its diverse array of creations, spanning from the logistical capabilities of handles to the revolutionary impact of stretch-on warehouse automation.
Boston Dynamics' Electric Atlas claims the crown in 2026. Retiring hydraulics for electric actuators, Atlas achieves superhuman strength and agility. Backflips, running, and object manipulation on uneven terrain. Titanium and 3D printed aluminum yield 28 joints with modular grippers. Reinforcement learning exceeds human flexibility. Hyundai pilots target construction and disaster response. With lithium-ion endurance and commercial rollout in 2026, Electric Atlas is the pinnacle of robotic athleticism. The fully electric Atlas wowed us with insane agility, acrobatic flips, dynamic whole-body manipulation, and even creepy efficient stand-up moves. Partnering with Hyundai for factory pilots and integrating advanced AI, like large behavior models, Atlas set new standards for power, balance, and real-world industrial tasks. The new Boston Dynamics Atlas is IP27 certified. But what does that really mean? Let's take a closer look at its features and capabilities. The production-ready Electric Atlas Humanoid from Hyundai-owned Boston Dynamics made its historic public debut at CES 2026, rising dramatically from the floor on stage to demonstrate ultra-fluid human-like movements, precise object picking from shelves, heavy payload lifting up to 66 pounds with advanced three-fingered grippers, and industrial-grade agility designed for real factory deployment starting in 2028. The new Electric Atlas robot from Boston Dynamics, unveiled at CES 2026, represents a major leap toward commercial humanoid robotics with its fully electric design, 56 degrees of freedom, 2.3-meter reach, and ability to lift up to 50 kilograms instantly, making it ideal for demanding industrial tasks like material handling and parts sequencing. The new Atlas robot features self-swappable batteries that enable continuous operation, providing approximately 4 hours of runtime during typical industrial tasks before the robot autonomously swaps them out in under 3 minutes. Production has begun immediately at Boston Dynamics' Boston headquarters, with the entire 2026 output already fully committed. Fleets are scheduled to ship soon to Hyundai's Robotics Metaplant Application Center and Google DeepMind for initial real-world deployments and AI integration testing using Gemini Robotics Foundation models. Hyundai's deploying tens of thousands across factories, starting with their new Metaplant America in Georgia. Spot, the dog bot, is already inspecting welds there, but Atlas rolls in later this year for manipulation tasks like part sequencing. Vice Chair Jae-hoon Chong says, "Physical AI and humanoids will transform our business, aiming for robotics leadership by 2035, when the market hits $38 billion. Boston Dynamics CEO Robert Plater calls Hyundai their biggest customer ever. Atlas's new electric actuators mean better dexterity for heavy, irregular lifts. Think grabbing tools or navigating uneven floors. With Hyundai's $21 billion U.S. investment, including $6 billion for automation, Atlas could be reinstalling car doors or assisting in EV assembly. They're pairing it with exoskeletons and unmanned vehicles for a full mobility ecosystem. Hyundai's not just testing, they're building the supply chain from components to smart logistics. The versatile quadruped robot Spot joined Atlas in captivating synchronized performances at the Hyundai booth, highlighting its proven real-world applications in inspection and data collection across over 40 countries, with enhanced group coordination and entertainment features that thrilled crowds. Boston Dynamics also showcased earlier versions of its Atlas and Spot robots, taking attendees back to the company's early innovations. The display evoked a strong sense of nostalgia, highlighting how far the technology has evolved. Hyundai's eccentric wheeled mobile platform, MobiED, showcased its unique omnidirectional mobility and stability, ideal for transporting goods or serving as a dynamic base in diverse environments, adding an innovative twist to mobility solutions at the event. The MobiED robot is used for autonomous last-mile deliveries and logistics tasks, leveraging its eccentric wheel mechanism and AI navigation to maintain stability while traversing uneven terrain, steep slopes, and obstacles in both indoor and outdoor environments. The latest demonstration video showcases the platform's adaptability through fluid navigation and task execution in real-world settings. Key highlights include seamless integration of mobility and functionality, enabling applications from education to industrial automation. Developed with a focus on user-centric design, MobiED lowers barriers for robotics enthusiasts and professionals alike.